Hello everyone, in this video I will provide the explanation for the three diagrams of functional modeling to help your understanding. After watching this video, I recommend you to cover the details in the textbook for your complete understanding. So, the three diagrams in the functional modelings are use case diagram, activity diagram, and use case description. Actually, the use case description is not a diagram, but for our convenience, I will call those three as the diagrams. Okay, so in this video, I'm not gonna explain slide page by page. Instead, I will cover three diagrams only. Okay, let's go to page 4. This is a chapter 4 course slide, which is already posted on the Google View, so you may download and look at this video, look at this file. So this is the simplest form of use case diagram. So as you can see, we can see several symbols. Actually, the use case diagram is drawn to represent certain business process for certain information system. In here, if you look at this, then you can see appointment system. This is actually the information system we want to build. So this is a target information system. So maybe this system will cover the appointment system of an hospital. So they simply named it appointment system. And let's look at this big boundary box. This box is called subject boundary. This symbol is the representation of boundary of the system. Inside of this box means something happens inside of the system and outside of this box. Outside of this box, in this area or in this area, it represents outside of the information system. So these stigmas are called an actor. Actor is not a representation of specific user. Instead, it represents certain role of users. So there can be a lot of patients like Jane, Mary, or Tom, John, but actually we don't want to specify certain person. Instead, we just want to provide certain role called patient. So these actors are related to this system and interact with this system. So actually the purpose of drawing this diagram is to show what kind of business do we have in our system. Here we have actors, and this system, appointment system, will operate certain business process. In here we can see several overs: manage appointment, produce schedules, record availability. They are list of business processes covered by this appointment system. So to use this process, patient or management or doctor will approach to the system and will use this functionality of this system to achieve this business purpose. So we already identified three elements of the system, elements of the use case diagram: actors, subject boundary, and this oval. Actually, this oval is called use case. Use case is the representation of a chunk of business process. So in this diagram, we don't want to identify how to carry out certain business process. We just focus on what kind of business do we have. In appointment system, we have 3 business processes: manage appointment, procedures, produce schedule, and record availability. And 3 actors will be related to different business processes. So how can you represent the relationship? The relationship is represented by this solid line. This solid line is called association relationship. Okay. Then let's look at the details. We have a patient outside of the system. This patient will access this system and will manage his appointment, his or her appointment. Many times we access certain website and make appointment or change appointment or cancel appointment. This patient also will that type of thing using this system. Appointment system, you may consider this system as a website, because website is a type of information system. Then management of this hospital will access this website and produce schedules. And doctors also will access this system and record their availability. Once availability is set up in the system, then patient may access that information, but in here we don't want to show that type of details. Instead, we just want to represent what kind of process do we have, and we will assume that that type of information will be stored somewhere in this system. So once you meet database, then system automatically, we're going to assume that system will have database. So you may assume that system have database and information will be stored in that database. But in here, we don't want to show the existence of that database. And this cardinality means how many times this patient can access these business processes. Management can access this produce schedule many times, and these schedules will interact with many times with management. Same idea to doctor, same idea to patient. The details are shown in this page. So we can set up this much multiplicities. This type of number of access, this relationship is called multiplicities, and we can set up these multiplicities. So this is our simplest example of use case diagram. And then here we already covered actor and use case and subject area, association relationship, and then we have to consider these 3 special relationships: include, extend, or inheritance relationships. Okay, for that, let's consider this diagram. This diagram is a little bit extended version of the diagram. So let's look at this symbol first, inheritance relationship symbol first. So actually this is a relationship of inheritance, but former name of this relationship is generalization relationship. Actually, generalization relationship occurs when 2 objects have certain inheritance relationship. because you already finished Python programming, so I'm sure that you understand the meaning of inheritance. So classes can be inherited. Actually, the same thing can happen in between actors and in between use cases. So in here, actually, if you think about the situation in this direction, up to down, then you can consider this relationship as a specialization relationship. If we think about bottom to up, then it is considered generalization relationship. Look at this. We have two patients, new patient and old patient. They are all a kind of patient. Patient covers more broader concept, and new patient, old patient covers a little bit narrower concept. So if we go from patient to new patient, then we narrow down the concept. It is called specialization relationship. But if we consider old patient, new patient together, and we may consider patient information, patient actor, then it is generalization relationship. Actually, specialization, generalization relationships exist at the same time. So for that type of relationship, we use this hollow head arrow symbol. Okay, also we can do the same thing for the use cases. Here we can find manage appointment, manage old patient appointment, and make new patient appointment. Actually, make old patient appointment and make new patient appointment, they are a kind of managing appointment. So managing appointment use case covers broader concept, and make old patient appointment and make new patient appointment covers narrower concept. So we can use this symbol again to represent the generalization relationship. So we can apply generalization relationship for actors and for use cases. Then another concept we may think about is this extend relationship. This extended relationship is applied only for use cases, for in between two or more use cases. So let's think about the relationship between manage appointment and manage. Let's think about this example. This is much easier to understand. So let's think about make old patient appointment and update patient information use case. Here we have two use cases. So let's say that a patient alive at a hospital, the patient is old patient. The patient already have the record on the hospital, but once we alive the hospital, then nurse will ask, it is new to this hospital? It is your first time to this hospital? If we say no, then we become old patient. Then the nurses will say, any update of information? For example, during the time, if we change our address or phone number, then we will say, yes, I have to update my information. Or if there's no change on my information, then we will say, there is no change on my information. Actually, update happens optionally. Sometimes we may update information, sometimes we may not. We will not update the information. In that situation, we can use this extend relationships. So this is kind of submodule, and this submodule extend. Look at the direction of this arrow. Extend this module. So when making all the patient appointment, updating patient information can happen or cannot happen. That is the relationship of extend. Same thing applies to these two use cases. But if we think about make new patient appointment and create new patient appointment, then once we arrive a hospital and it is our first time, then nurse will ask us, it is your first time? Then we have to say yes. Then nurse will give us a bunch of papers, and we have to write down all of our information, and after receiving those information, nurses will enter those information to their system. In case of new patient, if we are a new patient of the hospital, then there is no way to avoid such a creation of new patient record process. It is not an optional, it is mandatory. In that case, we may use include relationship. Look at the direction of this arrow. This is a higher level and this is a smaller level, a lower level, and coverage of this use case is a little bit small, but we are using the arrow to this direction. So this is the idea of extend and include. So we extended from the basic, we extended some idea of generalization relationship. Actually, this is an inheritance relationship, and also we adopted extend and include relationship. So we may do the same thing in here and here. So this is all about use case diagram. Again and again, use case. The purpose of drawing use case is to represent what kind of business process do we have in our system. We don't want to describe how our system can do such a process. That is the concept of other diagram. Other diagrams will cover such a concept, but in here we just want to identify what kind of business process should be covered by our system. Based on your understanding from actual real-world business process, you have to draw this diagram. Then this diagram just covers what kind of business process. Then some diagram have to cover how to do this. That kind of procedure concept appears in activity diagram. So if you look at this diagram, then it is very straightforward. The symbol of these diagrams are very similar to those in flowchart. So this is the starting point and this is the end point. And this is the sequence of certain business process. Capture location, capture number of bedrooms, capture monthly rent, and add apartment. Maybe this is apartment registration. Maybe this flow is adding some apartment information to the system. And capture apartment identifier, delete apartment. Maybe this process is about deleting certain apartment record from the system. So like this. For each use case, if you go back to this use case, then there is no concept of procedure in this diagram, but actually if we think about the inside action happening inside of this use case, then we may think about this type of procedure. So in here, we want to show the procedure happening in each use case. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9 use cases in the use case diagram, then you have to provide 9 different activity diagrams. this is one activity diagram, this is another activity diagram, and each activity diagram, this one and this one, will cover different use case. So these are symbols used for activity diagram. So at the beginning of activity diagram, the developer of activity diagrams created these two different concepts to show a unit process, but actually there is not much distinction nowadays. So you can use any type. Actually, if you look at these symbols, then there is no difference. So we may freely use any of them. We may call this activity, or we may call this action. So it doesn't matter that much. And we're not gonna use this concept because developers of this diagram want to include some class concept, but in the actual industry, in the activity diagram, we just want to focus more on the business process itself, but class concept is about some IT related things. So in many cases, the developers of the diagram don't want to include class concept in this diagram. So this one is control flow and this one is object flow, but we're not going to use object flow because we're not going to use class name, but we can find these arrows in anywhere. That arrow is control flow, just meaning of sequence, after doing this, after doing this, after doing this, like that. And this is the initial node, starting point of the business process, and final activity node. This is the end of certain business process, like this in here, and like this, and like this. And final flow. This means that if certain subflow stops in the middle of the diagram, then we may use this diagram. But we may use this symbol in the diagram. But actually, this symbol doesn't mean that entire business process is over. It is the meaning of this symbol is certain part of process is over, but other part will continue. So let's look at a little bit extended version. Yeah, this one. Here we have two boxes. Here we have initial node, and this is separated by this big line. And we have two boxes, this box and this box. So if we go to next one, then that box, this small box is extended vertically like this, and this is called swim lane. So these two processes go differently, separately. And also this is fork node and this is join node. So if we look at this, then certain process, one process is fork into two different swim lane, but after finishing separate operation, then it will be joined using join node. So they use join node here. Then process is merged into, actually move to one swim lane, and finally finish here. So even if it is not covered in our sample diagram, this is some kind of a decision node. It is very similar to if statement. For example, this diamond can ask certain question. If age is greater than or equal 9 or 19, then go to this flow. If age is otherwise, go to the right side. Once we divide divide the flow using decision node, then those divided flow should be merged in merge node. So in here, example is just the branches are divided in 2 directions, but as you want, then you may use 3 branching, or but 4 branchings, but recommendation is at most 3 branches. And also you may specify decision criteria. For example, in here we may ask if it is greater than 9, then answer is yes, then go to here, and answer is no, then go to this flow. So in between these 2 options, 2 branches, they should be exclusive. There should be no overlap between these 2 conditions, or there should be no gap between these 2 conditions. Okay, that's how you use to decision node, merge node, fork node, join node, and swim lane. Actually, fork node and join node and swim lane are used together very frequently, and decision node and merge node are used together. Once we use the branch node, decision node, then we have to merge those branches in certain merge node, in merge node. Okay, that is activity diagram. So again, the unit of activity diagram is one use case. So again, if you have 9 use cases in the use case diagram, then you have to provide 9 different activity diagrams. So use case diagram, activity diagrams are not the different ones. In the use case diagram, we want to represent what kind of business process do we have. Then in the activity diagram, we want to show for each use case, process is like that. We want to represent such things. For this use case, flow is like that. For that use case, flow will go like that. So that's why we have to provide one activity diagram per use case. But we just need to provide one use case diagram. In one use case diagram, we have multiple use cases. Then the number of use cases should be the same to the number of activity diagrams. Okay, they are 2 different actually they are the representation of certain business process, but we look at the business process in different perspective. Then let's merge them into a document. That document is use case description. So this is the sample of use case description. So use case description is a document like that, and it is composed of 2 parts, like this and this. So in this upper part, we just want to include the information in use case diagram. So the unit of writing this form is use case. So we can find the use case name. So if we have 9 use cases, then we have to provide 9 use case descriptions, one for each use case. So number of activity diagrams, number of use case descriptions should be the same. Also, the number of use cases in the use case diagram also should be the same. So that means those three documents, three diagrams are not the different ones. So we may describe actor and trigger when this process, this use case can be invoked, or we may describe some relationships. Actually, in the use case diagram, we represent this relationship using graphical notation, but in this document, we just want to write down those information in this form. They are different way of description, but actually they include the same information. And then the bottom part is composed of three parts: normal flow of events and subflow and alternate exceptional flows. Actually, this information should come from activity diagrams. So activity diagram is very similar to flow chart. They have concept of sequence. This sequence information should appear in this section, normal flow of event. So this number 1, 2, 3, 4, 5 means each number will be conducted in this sequence. After doing 1, then go to number 2. It is very similar to programming code, programming pseudocode. Instead of using certain keyword, we just want to describe in this way, but conceptually it is very similar to programming. So if we have certain decision, then we may use if. So in this description or in activity diagram, we will assume that all cases will be done successfully. We're not going to assume that because we want to represent the flow of certain business process. If we try to, for example, if we try to record certain patient information, then there will be no errors. After recording, after we're going to read and we're going to modify, we will, as we want, then flow. Each unit of action will be successful. So if certain same type of action is repeated, then we may describe them in subsection. So if we go to the next page, then let's look at this. Then these are kind of sequence of action, but in here we can see if. This is same to decision node. This one. This diamond represents if. So we can describe if. And we can find, because this is repeated, so they want to, or for the readability or simplicity of the information, in this section we may use S1, and this will be connected to here. Details of S1 process is described in here. S2 is described in here. S3 is described in here. It is totally up to you. If we include all this in here, then this part is too big and hard to read. That's why they separate S1, S2, S3 process in subflow section. And we always assume that each unit of action will be successful, but if we want to specify or some special case or alternate or exceptional flows, then we may use this section, alternate exceptional flow section. So Same idea. S1. If something happens in here, then it is related to. And that special case is S1, to A1. Another case happens, then this is described as S1-2A2. Like this. In case of subflow and alternate exceptional flow section, they used some special cases, but at least you have to provide normal flow of event section when writing use case description. So the information in use case description and activity diagram and use case diagram should be the same. Even if we don't have any activity diagram, use case diagram, but if we just have use case description and if we follow these steps and these information, then we should be able to draw use case diagram or activity diagram. Or having just use case diagram and activity diagram, then we should be able to create use case description. Again and again, we are not looking at different business process. We are just looking at the same process in different perspective. In the use case diagram, we just want to look at what kind of business process do we have. And activity diagram, for each use case, what kind of flow do we have? And in use case description, let's describe the information in the form, detailed way using some description. That is how to create use case diagram, activity diagram, and use case description. They are not the different ones. They are covering the same information. Okay, these are all about 3 diagrams. So even if this information, hands-on exercise information, is in the syllabus and other documents, but you have to finish the hands-on exercise. So looking at this slide is not enough. If you don't have clear understanding after watching this video, if you don't have clear understanding, then go to the textbook and make some sense in your mind and do the hands-on exercise. By doing the hands-on exercise, you will learn and understand more clearly about those 3 diagrams.